just bear with me for a moment while I bring up our agenda. And let me go ahead and share that out. And so essentially what we're going to do, and for those of you that have heard me present before, sort of have a pretty good feel for the agendas that I usually put together. We're going to start off with some of the storage-related topics. So, and I like to sort of split this down the middle, with part of this being PowerPoint, Visio diagrams, the second half being more practical, where we'll go into the lab and we'll actually look at how to apply some of these principles, and we'll do a live Q&A at the end. For the Q&A, I would encourage you to go ahead and get your questions in directly through the GoToWebinar user interface. That is something that I'll go ahead and be monitoring, and then when we get to the Q&A section, I'll go ahead and start answering questions. If for some reason your question doesn't get answered live, as long as you've typed it into that interface, we'll have a record of it, and we will follow up with you directly one-on-one to go ahead and answer your question. If your question relates to something more specific, just perhaps your environment, or if it's something that I simply don't know the answer to, we'll certainly get back with you once we've got an answer for you. But as you can see here, we're going to go through and do an overview of storage technology. Then we're going to get into Iscuzzy along with SharePoint. In this case, I'm going to be talking specifically about Iscuzzy, SharePoint, and Hyper-V. So we're going to add Hyper-V into that, and I've got a lab set up where I'm hosting a SharePoint virtual machine along with a virtual SQL Server database, and we're going to talk about the setup there and some of the storage options that are available to you using Iscuzzy to support both of those environments. And so, both from the Hyper-V perspective, and then hosting that SharePoint server, and really talking about the content databases being on a separate SQL server, whether that be physical or that be virtualized, and then the ability to go ahead and sort of tie all that together with an Iscuzzy or IP-based SAN. Some of the specific, features or topics we're going to cover when it comes to storage, the shared storage requirements, obviously, and that's really more of a big picture slide where we're going to talk specifically about, how that works or how it looks from a 30,000-foot overview perspective within your environment. We're going to talk about continuous data protection and snapshot data protection, how to combine these two to be able to do things like rollback or recover individual objects, database files, to be able to go ahead and, when you're using this in a SharePoint environment, be able to go ahead and create recovery points throughout the day by utilizing things like the continuous data protection and the snapshot-enabled volume to be able to really get to a point where if you have an issue between backups, you can get that content database back to a particular point in time. Then we're going to talk about high availability and MPIO and how that relates to SharePoint. So, and a lot of you out there will be looking at maybe creating, multiple SharePoint servers back-ended by multiple SQL Server databases and being able to go ahead and tier those, so introducing that tiering strategy. Some may require high availability, while as others, simply won't. You can use asynchronous replication, maybe to replicate data off-site. So these are all topics that we'll touch on. This is obviously meant to be a very high-level overview. So if you're somebody that, is looking for anything specific around your environment or want to really sort of roll up your sleeves and get down to sort of some of the nitty-gritty around SharePoint, SQL Server, Hyper-V, and then ultimately Iscuzzy, that's something that, and it's something that's not covered or something I don't cover here, let us know and we'll jump on the phone. We'll do a, sort of a private webinar for you where we'll answer all of those questions and make sure that, we get to the bottom of your question or get to the bottom of a scenario where, talking about the environment that you're specifically looking to implement. With that said, let me go ahead and jump right in. Now, I always like to start these sessions off with an overview of storage in general, and specifically, a central storage environment. So, what better way to sort of kick that off with some of the more traditional technologies, that being, and I've chosen here, fiber channel SAN. Because it's a concept that maybe not all of us are familiar with intimately, but we've all heard of it. We all sort of know who EMC is. We know who the big players are in this market. And it's always good to start off by sort of comparing this to, sort of what we're going to focus on today, which is iSCSI and then specifically software-based iSCSI. This obviously is a technology that we're all, heard of, and, obviously it's one that has been around for a while. And I think that, one of the things that we always think of when we think fiber channel technology or fiber channel SANs are the costs that are associated with this. And so, for a lot of us, we're simply priced out of that market. We don't have the ability to go ahead and absorb the upfront costs that are associated with implementing the fiber channel HBA in each, of my application servers, whether they be, regardless of the hypervisor that you're using, whether it be Hyper-V, Zen, ESX, or the application, you've got to have that fiber channel HBA, which, on the one hand, provides that dedicated bandwidth, which is exactly what it's intended to do. However, it is expensive to go ahead and start porting those into each and every machine, never mind if we start talking about redundancy and sort of what the cost that could potentially be associated with that. The same thing with the fiber channel switch, so some dedicated switching technologies that, once again, could potentially cost or put us in a situation where we're priced out of this market. And then if we move down to the storage layer where we actually have the fiber channel SAN itself, again, lots of dollars, lots of upfront costs. So you're basically, now obviously the principles that apply to sort of a central storage architecture still apply, and the ROI still applies. But you're simply going through and stretching that, that time to recover those costs, or the ability to recover the costs associated with that investment by simply going through and putting up a lot more money up front with regard to that. Now, we look at that in contrast to the iSCSI SAN. So now we're looking at a scenario where we're looking at utilizing some of the more commodity-based networking equipment to go ahead and accomplish essentially the same model. So if we look here, we're talking about instead of fiber channel HBAs, gigabit network adapters, standard gigabit switching technology, standard Cat5e or Cat6 cabling, and then we get down to the iSCSI boxes, and again, this is where the road forks again for us, where we start looking at things like, software-based iSCSI versus the hardware approach, and really sort of looking at this, in a scenario where you have an opportunity to choose basically which approach you want to take. And we're going to delve a little bit into that today. But again, anything from the storage layer on up is, sort of a scenario where, again, we're talking about just commodity-based equipment, off-the-shelf equipment that you're all familiar with, you've all administered in the past. You've all set up networks utilizing this equipment. And then when we get down to the storage layer, again, we're still talking about that commodity-based scenario, but now we're talking about a choice between an iSCSI appliance, like, a Drobo, or, if we go a little higher end with the Dell Equalogics or the HP left hands, then we're talking about that sort of appliance-based approach, which, again, that could also present some cost issues for us. Or we can look at the software-based approach, which is now where we're looking at, the StarWind softwares of the world or the data cores of the world, to go ahead and be able to customize that iSCSI box, to be able to build that out based on a budget that you've got in mind, and really go ahead and put the dollars where they need to go. And what I mean by that is, if you need to focus on, disk subsystem performance, well, then we can make sure that the dollars go there. If you're inheriting, say you're repurposing a box, you want to focus on, caching of the I/O. You can focus on spending dollars on additional memory for these boxes. So, we can sort of tweak what the Iscuzzy box ultimately looks like to make sure that, you're getting the most bang for your buck, so to speak, on the Iscuzzy front and on the storage front. But again, looks a lot like what the fiber channel SAN looked like in terms of we're looking at, an application layer and a storage layer, only now we're not utilizing that sort of proprietary hardware approach or that proprietary networking approach. Everything is done sort of off the shelf. Now, this slide here, and I think that I like to talk about this because it really does apply to anything that you might be looking at, any application that you might be looking at, and whether you're talking about, a standalone or a series of standalone servers, or you're talking about, implementing a hypervisor, to help virtualize or go through a server consolidation. I like to take a step back and look at why does considering a SAN implementation make sense. And it's really a lot of the same reasons why a server consolidation makes sense. Because you've got, if you think about sort of what you're doing with standalone servers, is you've got a bunch of servers out there that are operating with their own individual pools of storage, which they may or may not be utilizing to the full extent. Or maybe you're looking at a scenario where you've purchased a bunch of storage for these servers and, they're slowly building up to it, but you've got a lot of wasted space out there. You've got disks that are turning, that are, aging, that aren't being utilized fully. So you've got sort of an underutilized sort of resource in your storage. And so, we look at sort of that central management of storage resources, whether you choose Iscuzzy, Fiber Channel, NAS, whatever the protocol you choose, the fact remains that being able to, sort of more centrally manage those storage resources and be able to parse those storage resources out on an as-needed basis makes for a much more cost-effective way to manage your storage. And the other nice part about this is, you can also offload a lot of the data protection that needs to happen to the SAN as well. So when we start talking about going through the process of whether it be mirroring data or snapshotting data or creating a high availability scenario for your SAN, we're talking about protecting data at the storage level so that we can remove some of that burden. So, you don't have to go through and simply implement, say, database replication, database by database by database. You can now go ahead and assign those databases to a storage resource that is then replicated at the block level. So, there's a lot of efficiencies that present themselves, outside of the cost savings and the more efficient use of storage assets that, in terms of data protection, disaster recovery, planning, and high availability. And then obviously for a lot of us, especially when we're looking at something like SharePoint or any other sort of enterprise-level application, we start looking at sort of virtualizing that and, the risks that are associated with sort of that all your eggs in one basket or all your eggs in 2 or 3 baskets, whereas before those eggs are spread out across maybe 20 or 30, and if you lost a server, there was only one application that was impacted or maybe some subset of your user population. Now we're talking about a scenario where if you lose a server, you could be talking about 4, 5, or 6 different, applications that are impacted. So, implementing things like, clustering for Hyper-V so that you can go ahead and, make sure that you've got a high availability scenario or some sort of recovery scenario for those virtual machines, which obviously requires a shared storage component. So, there's a lot of reasons to consider a shared storage or a centrally managed storage environment, and those are just a couple that I like to touch upon as we go through this. Now, the other thing that I'm here to try and convince you of today, obviously, is the software approach to building out an Iscuzzy SAN. As I talked about earlier, there are, really, sort of the road forks at when you've made the decision to look at Iscuzzy based on, everything from the storage layer up, so your networking piece. You've made that decision, but now you want to decide between, do I want to go with an appliance-based approach or a software-based approach? There are a lot of reasons really to strongly consider the software-based approach. The majority of it revolves around flexibility, whether it be flexibility around the hardware that you want to use, flexibility around, having a limited budget and being able to apply the dollars to the areas that are most important to you, with, not having those decisions taken out of your hands. And the ability to really go ahead and build this out, whether it be with a budget for new equipment or with, a partial budget, to maybe augment some existing equipment, you're really going to get the choice of how that's going to run and what that's going to look like. And so, the software-based approach, ultimately you wind up with the same thing. You wind up with a server with a bunch of storage in it that's, basically being parsed out to the application layer, LUN by LUN, but ultimately, you're going to choose whether or not you're going to build that out yourself using the equipment you're comfortable with, or you're going to let a vendor choose. You're going to basically say, okay, I want this appliance, and, basically be handed that and go from there. So, and I think that there are a lot of factors that go into it, and certainly, for those of you that are looking to do this on sort of a tighter budget, certainly don't make that decision without having a conversation with us, because I think it really, there's a strong sort of movement toward this whole almost a DIY type of shared storage environment where you can utilize software to sort of put this thing together and really put together a really robust storage infrastructure without having to spend all the dollars that you might initially thought it was going to take. Now, obviously when we talk about software, Iscuzzy, and then, we sort of fold that into, and maybe I did these in reverse order, why should you consider Iscuzzy? And I think that, the first couple of slides sort of gave you my position on it, and I think that if you really think about this, you're talking about a scenario where, with 10 gigabit Ethernet now, there's no longer that concern with bandwidth. And quite candidly, I think that the bandwidth problem with the advent of MPIO and the robust switches that are available to you now, we could overcome that regardless. I think that, we're talking about, maintaining a scenario where, if you need fast disk, if you need, something that rivals fiber channel, then great. If you don't, you have the option to go with something a little slower, maybe, something that's a little bit more cost effective. Managing this, obviously, you don't need a separate subset of skills. You don't need to bring in a storage expert, to manage your storage environment. You're going to manage this network just like you manage all the other networks that are utilized in your organization. So, again, Iscuzzy really presents an opportunity to put together a shared storage environment without having to go through all of the issues that are associated with, setting it up and the large costs up front by, bringing in the proprietary networking. So really something that is reliable, scalable, and affordable, I think is the key. Now, I always leave this slide in here because I never know sort of what the makeup of the audience is going to look like. So this is just a basic sort of terminology slide in terms of what is Iscuzzy. Think about, the interaction between your disk when it's plugged in locally. And so ultimately there's, the motherboard, there's the bus that basically the disk attaches to, and the commands are issued, across that bus. This is the same thing. We're talking about the same scenario, only this time we're leveraging the TCP/IP stack and some initiator technology, whether it be a software-based Iscuzzy initiator like the ones from Microsoft, or like you might see in Zen, or you might see in VMware. We're using that, or a hardware stack where you've got a software or a hardware-based host bus adapter, an Iscuzzy host bus adapter, much like those put out by QLogic. Again, a very good piece of equipment, and what that does is it offloads all of the processing of iSCSI onto that particular card. So no longer do you have to worry about the resources that potentially could be utilized by the software stack. You basically go ahead and offload all of that. So basically what we're doing is we're taking those traditional disk commands, encapsulating them via TCP/IP, and transmitting them over, a dedicated network, down to the storage servers, which are, then presenting those iSCSI volumes and are actually interacting with the physical disk subsystem to go ahead and pass back confirmations that the writes have been committed, or taking those .io, those blocks, putting them in some sort of cache or holding area while the disk subsystem goes through its processing. So that's kind of what we're talking about when we talk iSCSI. Obviously, this benefit slide is a little bit redundant, using familiar networking standards, offloading data protection features, eliminating the cost and overhead of proprietary hardware installations and networking. And the other piece that I always like to mention here is it does fit very well in a mixed environment. So, if you're a customer that's already, implemented a fiber channel SAN, there's no reason not to look at iSCSI, because I'm betting that on that fiber channel SAN is data that probably does not need to be there. You don't need that level of performance. You don't need that, there's probably another tier that needs to be built in there to go ahead and offload some of this to. And so, expanding that storage area network, and when we talk about that term, we're encompassing all of the storage technologies to maybe use iSCSI to expand that storage area network that you've set up so that it doesn't have to be exclusive to fiber channel. The other thing that people always talk about are performance issues. And so, I like to talk about some of the performance best practices right up front. And this is something that, trust me, this is a conversation. If for some reason you're nervous about this or you're not seeing a level of performance, please don't be shy. Let us know. But these are some sort of best practices that, we want to make sure that you, sort of follow as you start to look at this. First and foremost, network isolation. So, much like the fiber channel piece, and the fiber channel forces you to do it by forcing you to use a proprietary network fabric, iSCSI, we're going to ask you to go ahead and set up an isolated network for this, only using the commodity hardware. Network optimization. So, enabling jumbo frames is sort of a no-brainer here to make sure that you optimize the network so it runs as efficiently as possible. This is a little dated, and then optimizing the TCP/IP window size sort of goes away with 2008. So the TCP/IP stack there is sort of self-optimizing, so it's less of a concern. And then we get down to the disk subsystems. Things like, some of the more common mistakes I see made here, and it'll relate specifically to SQL Server type of workloads that are associated with either, some transactional application or something like SharePoint, where, the RAID set is configured incorrectly. You don't have the proper use of disks, so you're not making the right disk selection. Whether it be SAS versus SATA, you're not mixing them correctly, or you're not utilizing the right type of disk speed and density to drive the level of performance you're looking for. And then something simple, that I always like to talk about here is matching, those RAID sets or the physical volumes with the I/O patterns. So there's nothing that'll create a bottleneck faster than trying to, and it won't be a bottleneck consistently, but, the potential for a bottleneck is there if you start doing things like matching random I/O with sequential I/O on the same set of spindles. This could very quickly create the bottlenecks and cause a ripple effect throughout the environment, making things slow down. And then monitoring, obviously, we don't like to think of these things as, a black box you're just throwing in the corner. You have plenty of tools available to you from a Windows perspective. Things as basic as looking at the disk queue length or the physical volumes that you're utilizing for iSCSI. These are going to be important things to make sure that you do and monitor those to identify bottlenecks before they impact the entire environment. The data protection we talked about, block level replication. We're going to get into some more of this detail when we look at some of the content-specific slides. So I'm going to go ahead and pass over this pretty quickly to get to this. Now, this is really where, I like to show sample of the topology of what something like this might look like. Now, I know there's a lot of you out there that, will jump down my throat and say, where's the second switch? Where's the redundant? Now, this is meant to be something very, very basic, just to show, some of the basic moving parts. And I also set this up to show two different scenarios here as well. So, obviously, when we start talking about SharePoint, we're talking about, something that you're trying to create an environment where, the groups of users are going to have sort of a common workspace, a collaboration type of scenario, an area where you can publish documents. So it's very content intensive. And so, one of the things that you want to make sure that you're prepared for is, what am I going to do? How am I going to protect this data? Because when we look at SharePoint and we look at how it's utilized or implemented, and we start talking about, the original sort of cloud computing, which is that private cloud or that sort of one space that's being utilized by multiple organizations or multiple departments within your organization, the one thing that's consistent about SharePoint is it's constantly changing. So the potential for that data to change. This is not something where an IT administrator is going to have a lot of control over. We're basically saying to the end users, here are your sandboxes, and we want you to go ahead and start using these to collaborate, to store and publish documents, to do a lot of things. And so we're constantly changing. That data is constantly changing, but it also presents some significant challenges around, once the end user starts to, utilize this or really sort of get down to making this a part of their daily routine, they're very upset when it's no longer available. And so we have to start off when we look here, and I like to sort of apply this SharePoint template to some of the more generic diagrams that I was talking about earlier. As you can see in our application layer, we've got our SharePoint servers. Now, one of the things that's important to understand as well is that, those of you that are looking at virtualization, in this case we're going to focus on Hyper-V, these could be virtual machines. So your SharePoint farm could be a series of VMs that are connecting to, a centralized SQL Server scenario where, you're going ahead and either virtualizing SQL Server as well, or, perhaps you've got, sort of a set of physical machines that are serving up your SQL Server, or you've got a SQL Server cluster. And, as I talk about this, the need for shared storage just continues and continues to grow. So as we look at, SharePoint and the SharePoint piece here, obviously we're talking about, the virtual machines and their virtual disks ultimately being stored on shared storage. So, that's why I've made these or diagram these up as part of the storage area network. It's really the Hyper-V host that's connecting and ultimately storing the OS or the virtual disk that's associated with this SharePoint network. Now, obviously, the front end of this is going to have a whole, and if I were to continue the diagram to the left here, we'd see the user community over here. And obviously, these SharePoint servers need to be networked so that, they're connected to the corporate LAN ultimately, and then, obviously also networked to their SQL Server database. But as you can see here, we move from the application layer where we've got our SharePoint servers, whether these are physical or virtual. We've got our SQL Server servers down here as well. And again, we're talking about the content databases for these SharePoint servers. And so, we're talking about whether this be, again, a Hyper-V virtualized type of SQL Server scenario, and there's a lot being talked about now in terms of virtualizing the database workloads, or, if you decided to go through the process of, basically maintaining physical boxes for this SQL Server environment to back-end SharePoint. And you notice I threw a little box in here, just to sort of round out the piece, with the Microsoft DPM server, which you might potentially have connected over here to, say, another piece of shared storage, whether it be StarWind virtual tape library or something along those lines that's serving as a backup utility for all of this. Now, where this all starts to fit in is when we go over to the storage layer here, and sort of this is where I want to go ahead and tie together the application layer and SharePoint, SQL Server, and Hyper-V to the Iscuzzy piece. where we're talking about, obviously our if we move, from left to right here, our user community would be over here. They'd be interacting with these front-end servers, our SharePoint servers, which would then be interacting with the SQL Server database servers here. And if this was, a little bit closer to correct, I think I should have moved the SQL Server database over here, and that this is sort of a separate layer. And then they're all connected up to our storage layer. Now, our storage layer, in this case, consists of the StarWind Iscuzzy SAN, and there are two sort of basic scenarios that I want to cover today. One is the high availability scenario. So in this case here, we've got an active high availability storage device where we're going to go ahead and present the storage as a multipath device to, say, this Hyper-V server hosting our SharePoint server and to this SQL Server database, so that we have storage high availability. So maybe in the SQL Server side, we've created a physical cluster for the SQL Server. Well, it doesn't do us a lot of good if we simply introduce a single point of failure when we get to the storage. So we're going to go ahead and present these databases volumes as highly available, active storage to that SQL Server or SQL Server cluster. If I were to virtualize this, the same would apply. I mean, I would want to go ahead and potentially present that high availability storage, that active array to my hypervisor, to my Hyper-V environment, so that I can create the cluster that way. On the SharePoint side, again, if these are virtual machines, I want to potentially go ahead and, if I've got them in a Hyper-V cluster, I want to potentially go ahead and present them as high availability, or present the virtual disk as a piece of high availability or active storage as well. Now, option 2 here, or scenario 2, relates to some additional or continuous data protection, where what I'm doing here is I'm combining StarWind asynchronous replication with StarWind snapshot-enabled volumes. Now, up here, I don't necessarily get the level of protection that HA affords me from any sort of failure, but maybe here I decide to build out a bit more of a robust box. Maybe I go with dual RAID controllers and dual power supplies to sort of insulate myself from a potential disaster. But I do need to have a second copy of this data somewhere. So I want to go ahead and maybe asynchronously replicate this data. Maybe this is to an off-site location where I'm replicating it to a second StarWind box asynchronously. So all of my initiators, whether they be the SQL Server or the SharePoint boxes or the hypervisors that are hosting those SharePoint boxes, are connecting to StarWind for its storage. As blocks are written here, I'm replicating this data over to the second StarWind node, which is a passive node. Now, on this particular box, the other thing I can do is I can start to create snapshots or block-level captures of the data. So as the data is replicated, I'm creating restore points for myself. So I may use my Microsoft DPM server to back up SharePoint databases, but that may happen once a night. But rather than go through the process of maybe setting up log shipping or database by database replication, then maybe I want to go ahead and snapshot the volume as it's replicated, which will allow me to then go ahead and use the StarWind snapshot-enabled volumes to mount these snapshots and do things like file-level recovery. So if I do have a file that's blown away, I could simply go ahead and mount that snapshot as a read-only volume and recopy that data, rolled back to that particular point in time, back into my production environment on my active sandbox. So again, a lot of different options in terms of protecting the data, but the idea behind this is, with SharePoint and with a lot of us that are implementing SharePoint, we're looking at a scenario where we're going to have a lot of users and the data is constantly changing. And this becomes the challenge, is how do I go about, because this is really meant to be a collaboration space. And, we're going to, there are some controls, but, in general, we're talking about an application that is mainly end-user driven. And so, this is going to be something where we want to make sure we're able to protect that data, not only from, a nightly backup perspective, but make sure that it's available. We provide the level of uptime that's necessary, and that we also have a mechanism to go ahead and do things like restores throughout the day. So if I want to snapshot these volumes, 3, 4, 5 times a day, I've got something other than my last nightly backup to go to. So again, as you can see here, we're talking about a pretty comprehensive look at an environment where we're implementing SharePoint with shared storage. Now, this next is meant to be sort of a blow-up of the sort of continuous data protection and file-level recovery options that you have from the storage perspective. So this is set up as an active-active scenario, or an active-passive scenario, I'm sorry. And this is basically where we have our initiator machine connecting to the active storage box here. That data is then replicated down to the passive node. This passive node is then taking continual snapshots throughout the course of the day, so that if I find myself in a position where at 1 o'clock in the afternoon I get a call from a bunch of users that have said, geez, there's a problem, somebody's blown something away, somebody's done something, and the SharePoint is no longer available, or if a specific file is gone, or the database that back-ends their particular SharePoint application has become corrupt, I'm in a position where I can go ahead and restore that based on that last snapshot. So I can simply mount one of these snapshots on this passive node as a read-only volume, and then ultimately copy that data over to the active SAN, thus restoring it and then bringing that database back online, then making that SharePoint service available again to that group of end users. So that's sort of one level of data protection outside of the nightly backup that's available to you by using shared storage. And then there's the high availability piece. And again, when we start talking about Windows environments, we start talking about things like Windows updates and patching. And so you want to make sure that if you're utilizing SharePoint and you've virtualized the SharePoint servers, that you want to maintain a level of uptime. So you want to make sure that you've got this set up in an active-active scenario where you could bring one of the storage boxes down, whether it be intentionally to do things like a Windows update, or if one of the storage boxes simply has a problem or goes bad or loses network connectivity. That level of redundancy is going to allow that second node to simply take over and without any manual intervention and maintain that level of uptime that your users are going to demand. Again, we're talking about a scenario when you roll out something like SharePoint, it's a very addictive application to the users. The user will, want to go through a self-service portal maybe and set up their first sort of collaboration site. And the next thing you know, folks are relying on this as an everyday tool. So they want to, rather than have that document local, they want to store it in that private cloud or on SharePoint. They want to make sure that it's available to everybody. They want to be able to go in and edit that document or make comments on that document. So the high availability piece here in terms of back-ending your SharePoint implementation becomes very important. Now, with that said, I want to move over to more of the live demo piece, and then once I get through that, we can actually take some questions and talk a little bit about any questions that you guys might have or whatnot, and we can take it from there. What I want to start out with is the storage side of this. So I'm going to work from the storage and then work my way up to the application environment. I've got a Hyper-V cluster here that's supporting both a virtualized SQL server and then a virtualized SharePoint server that I've got online here. So, this is, when we start talking about the storage and we talk about, just to go back to that for a moment, we're talking about, software-based Iscuzzy. So we're talking about a scenario where I've basically built out a series of storage boxes and I've basically gone ahead and installed a Windows OS on them, whether it be 2003 or 2008 R2. I can run on the core if I want to sort of reduce the footprint there. But ultimately, I've got a series of storage boxes here, and I've got a couple of different types of devices set up. I've got an HA device that's being served up as to my my Hyper-V cluster. As you can see, I've got a Quorum drive here, and then I've got some data stores. And so ultimately, these are being served up to that SharePoint environment that I virtualized. Now, to give you a sense for what it looks like to create some of these storage devices that I've made reference to, I want to take you through a demo of how this works. Then we'll go over to the cluster button here, and I'm just going to go ahead and do test one. Now, the thing with StarWind, and we give you a couple of different options here when you're creating storage to share out to these environments. Obviously, hard disk is what most of us are going to be looking for. I mentioned a tape option. We do have the ability to, if you're using something like Microsoft DPM, we give you the option of going ahead and actually creating virtual tape devices, so you could take Iscuzzy disk-based LUNs and present them to your DPM server and set up a both short-term and long-term type of backup strategy. Or, you could use a physical tape device that you might have in your storage box to pass it through and back up to that. On the disk side, you have a couple of different options. One is the physical pass-through, which doesn't afford you much in the way of data protection. It basically allows you to take raw disk and simply pass it through as, an iSCSI target. Now, this is something that, we see used from time to time, but more often than not, folks are going to choose to use the virtual storage option because that's really going to give you the most in terms of flexibility. Basically, what you're doing here is you're going through the process of creating a virtual storage device on top of a physical storage platform. Basically, your basic virtual disk, think of that as, almost like a Microsoft virtual hard disk. It's similar to that. And then our advanced virtual disks, this is really where we get into a lot of the techniques that I talked about earlier in terms of data protection from the storage level. We start talking about what we call a mirror, which is our asynchronously replicated device, where you've got an active box and you've got a passive box. That passive box can be set up to do things like snapshots so that you have restore points throughout the day. The snapshot enable volume, as I talked about just a second ago, the ability to go ahead and do snapshots and provide continuous data protection so that, you don't leave off from, your scenario where you took the last nightly backup, nor do you have to go through the process of setting up things like log shipping or database replication on a database-by-database environment, which obviously can get very administratively intensive and, rely heavily on or create a large workload for your DBA group where you can accomplish the same level of replication by doing it at the volume level or the storage level. And then our high availability device. This is, again, where we're going ahead and presenting, two StarWind targets as an active multi-path device, where basically there'll be two active paths to the storage with a synchronization channel in between. And your initiator, which in this case could be your SQL Server database that's hosting, or your SQL Server that's hosting your content databases for SharePoint, or the Hyper-V hosts that are actually hosting those SharePoint servers for you, you're going to be talking about presenting two active paths to the storage, which gives you the fault tolerance that you need for those storage or for those SharePoint servers or for that database server that simply cannot afford to be down. Now, when I do this, or when I create that high availability device, the first thing it's going to do is it's going to ask you for the second host in this particular scenario. So I'm going to have two physical storage servers. In this case here, we'll go with 168.1.80. And then it's going to ask me for the login and password for, oops, I got the caps lock on here. Let's shut that off. and it's going to go out and do a quick check to make sure that the StarWind service is indeed on that second box for high availability, and it's ready to go ahead and create a target for us. It's also going to tell us that on the partner node, it's going to create a second target. As you remember, I called the initial target test 1. It's going to create the partner target. It's just going to add the word partner to the end there. Now, this is the part where I want to make sure that everybody's clear in terms of how this works. This is the part where you actually are going to assign your virtual storage device. So your HA set is made up of 2 virtual storage devices, one living on physical server A and one living on physical server B. Now, what you're going to do here is you're actually going to assign this virtual storage device to a physical storage asset in these boxes. So in this case here, I'm going to create a new device, and you can see here the current server, which is the server that I'm currently creating the device on, and then the partner server. So I've got a file browser here where I can come out and simply go in and assign this physical storage device. And we'll call this. And I'm going to do the same thing on the partner server. Again, if I click on the file browser, it's going to go ahead and present me with what I have available to me for physical servers. Or physical volumes, I should say. And then I can go ahead and size it. And so in this case, I'm going to keep it set at 256 megs. But again, I'm creating this, and eventually what's going to happen is my initiator is going to see these 2 paths to the same storage device, but they're going to be different on different physical boxes. And there's going to be synchronization in between, which is going to make sure that these are exact replicas of one another in real time. Basically, what we're going to do is we're going to actually have a write that needs to be committed to both sides or both nodes before it's committed back to the initiator. Now, that synchronization channel is something that you choose here, and again, we're going to recommend if you're choosing the high availability option here that you dedicate. And what I generally recommend to folks is this is the one time that I'll recommend NIC teaming, because what I'll generally recommend to most folks in an HA setup is if it's feasible and the boxes are in close enough proximity to one another, you team a couple of NIC ports and actually plug them together via a crossover cable for that synchronization channel so that you eliminate any potential outside influence that could be had on this sync channel, by a switch going down or something along those lines. You choose how to initialize the set. In this case, I'm going to choose Do Not Synchronize because I know that they're both blank. And then lastly, I'm going to be able to choose, as I talked about earlier, my caching options. Now, obviously, one of the biggest challenges we have is, the limitations that are imposed on us by the speed of our disk subsystems. And, some of us can afford the super fast drives. Or some of us, simply are going to have to go with the 7,200 RPM SATA drives. It's basically what we can afford. This is a nice way to utilize physical RAM in these storage boxes to help smooth out the performance bottlenecks that could exist, or can be created by some of that slower, more dense disk. Now, obviously, this goes along with some responsibility in that, when you start, caching large amounts of I/O, depending on the size that you set this to, you could potentially be facing a scenario where a sudden power loss could create a problem. So we're generally, because these are Windows boxes, we're generally going to recommend to most folks that you use, some sort of battery backup with some power chute technology, so that in the event that the plug is pulled, whether it be via, some sort of natural disaster or something else, that the Windows server will shut down elegantly, and that will flush the cache down to the disk. And so we're going to go ahead and just set up our device here, and once that's done, we are finished. And that's going to go ahead then and give us the ability to go ahead now and present this high availability storage device to our initiators. And in this case here, let me actually pop into one of these boxes here, and I think I've got the Iscuzzy initiator up on one of these. We'll try over here. Yes, perfect. Okay. So basically from there, what we're looking at here in this case is utilizing the Microsoft Iscuzzy initiator in the case of Hyper-V to go ahead and connect to that shared storage. And so in this case here, if we look, I've got my quorum drive for my failover cluster, and I'll show you that in just a second. So if I look close enough, and I know it's one of these, and I'm not sure which one it is. Just bear with me for a second here. There it is. There's my quorum drive. And if I were to look here, because I've plugged in all the IP addresses that are associated with both my the boxes that make up my HA set, I can, come down here and look at, these drives, and I'll be able to recognize, if I look here at devices, and I look at my MPIO, I can see I have two active paths to the storage. I've got the path that leads to the .80 StarWind box, and I've got the path that leads to the virtual device on the .202 StarWind box. And again, from there I can go ahead and set my load balance policy or path selection policy, if you will, so that I can spread the load out across these two servers, or I could go with, something like least queue depth or weighted paths, depending on how what my strategy was from path selection and sort of what my link looked like between the two servers from a synchronization perspective. So again, that's basically connecting that storage up to the cluster that you're going to then go ahead and set up your SharePoint devices. And so here, I've got a SharePoint server that's running in Hyper-V, and it's being hosted there. I've also got a SQL Server box that I'm actually back-ending. In this case, I've chosen to virtualize this in a demo environment, but that SharePoint box is utilizing this SQL Server box to go ahead and host its back-end databases. And so again, I can carve out, a volume for each one of the SharePoint databases that I'm going to create, or the content databases that I'm going to create. And Iscuzzy will give me the flexibility to decide whether or not I need to use high availability for that back-end database, or if I need to use something more along the lines of asynchronous replication for that database. If I need to make sure that going back to last night's backup's not going to be good enough, I've got to go and be able to do something where I can recover a file that was deleted, an hour ago. Maybe a snapshot enable volume is going to be the way to go. But as you can see here, I've got my virtual machine with all of my databases here. And in this example here, I've actually created, and I've done it for my virtual center as well, I've created a separate volume here. And if you picture this SQL Server will be a storage head, and basically you'll connect to Iscuzzy and create several different volumes here. That would be either HA volumes, asynchronously replicated volumes, snapshot-enabled volumes, and you would go ahead and place the appropriate database files for that particular SharePoint application on that particular storage device. And so each particular database or each particular SharePoint application or content database could have its own separate level of protection, or that level of protection that's commensurate with its user community and sort of the needs of that user community. So that's sort of how that works. It's pretty straightforward once you get to the point where you've created your SharePoint databases, your SharePoint servers, you've got your SQL Server database set and ready to go, and you've sort of made the decisions around what type of storage devices you want to create on a sort of per database level. You're then in a position where you're to that sort of point where you have this, as we look at it from the 30,000 foot level, that sort of infrastructure here, where this is going to sort of make up your private cloud infrastructure, where now you've got sort of an all-encompassed scenario where you've got end users that are able to go ahead and collaborate, data that's protected both at the application layer by, say, Microsoft DPM, but also by at the storage layer, and maybe replicated off-site or is highly available if we're talking about clustered applications. So again, guys, that's kind of what this looks like, and that's I hope that gave everyone sort of a decent overview of sort of how these things operate together, and that's really what I'm always going for with these presentations. I'm trying to give you some sense for how all the technology parts fit together. And then, obviously when we get down to the details, we can talk more about that on a one-on-one basis. With that said, I'll take a quick sip of water here and then start looking at any questions that we might have, out there. So, obviously I've put some contact information for StarWind up. My name's Bob Boulay, as I mentioned earlier. You'll be getting an email thanking you for coming to this event. If you have specific questions and you're more comfortable, sort of asking them one-on-one, you can certainly do that. Or you can call us directly or email into us, and we'll be happy to make sure that we get back to you quickly. But let me go ahead and look at some of the questions that we have here that we've gotten, and see if maybe I can answer a couple of them here online while we're all here. I know we're getting close to the top of the hour, so I want to keep that in mind as well. Let's see. Are there any performance metrics reviews of StarWind versus Dell MD3000i, Dell EqualLogic, and HP Left Hand? Let me talk to our marketing folks on that. I know that we had done some things that sort of compared the two internally. The conclusion that we came to was you could rest our stuff on top of Dell equipment and essentially get no worse than equal results if it's done correctly. So certainly something that we can certainly do there without a problem, and I'll look into that and get back to you on a one-on-one basis. Let's see here. Discuss TCP/IP latency and data corruption. That's a great question. That's something that we get all the time. I think that one of the things that you want to, and again, this is something that clearly, anytime storage is something less than direct attached, you're pushing storage over a network. Those risks exist, and I think it really comes down to the mitigation of those risks. And that's when I talked about performance optimization, I should have also labeled that slide safety. That's why we talk about dedicated networking and redundancy at the NIC level, utilizing MPIO, not just for high availability, not just for, MPIO is more than just a mechanism StarWind uses for high availability, but also it allows you to address, storage down the path, multiple paths. So you could, if you were to look at that sort of 30,000-foot overview I put together, adding redundant switches, adding redundant network cards to make sure that you've got multiple paths to that storage, doing things like making sure that you've got jumbo frames enabled to address any latency, and continually monitoring the network. But I think that spreading the traffic out over multiple NICs, over multiple switches, in a very, very high bandwidth intensive environment is the best way to sort of insulate yourself from that. On the data corruption side, again, I think one of the things that where you sort of get into some of those risks is when we start talking. I don't care what technology you're talking about now, whether it be StarWind or any other technology that utilizes some sort of volatile memory for cache. You obviously have those risks there for corruption with sudden and unexpected power loss. That's why we always talk about battery backups, and this goes all the way down to the RAID controller, where if you're going to turn on caching, you want to have a battery that's associated with that as well. So there are mitigations around each one of those risks, and again, I think that if you've got want to talk about that from a generic sense, that's one thing. If you want to get into it within your specific environment, we're happy to do that as well. Let's see here. When we take a snapshot of the SharePoint content database at a time T, if I try to restore the same content to the database per the presentation, I may end up with inconsistent data. Yes, and so, I think that what you want to do there is, you certainly don't want to, and maybe I've oversimplified it, you certainly don't want to go through the process of, taking a scenario and simply just copying the database over. What those snapshots will enable you to do, and you can mount that snapshot that represents, that point in time of that database. The proper way to go about doing that is to, simply have, a shadow setup where you can go ahead and mount that database separately. So you'd mount it as a read-only volume, copy those files, those database files that were snapshotted at that particular point in time into, say, a test and dev or sandbox environment where you could mount that database, connect to it from a sandbox SharePoint, and pull those files out and then reintroduce those into the production environment. So the wholesale roll back and replace is ultimately, or file level stuff could present problems, and so that's a little bit more of a realistic way to do that. I may have oversimplified that a little bit, so I apologize for any confusion. Let's see, if I'm using StarWind for learning purposes, can you please tell me how to set everything in VMware Workstation 7? Sure, and that's something we can do on a one-off, so I'm happy to do that. If you want to contact us, we're certainly willing to spend some time with you and make sure that we get that done. And let's see here. If my content database and configuration database are on different volumes, then taking one volume snapshot does not ensure automatically. Absolutely. And so I think that there are obviously, and what I'm trying to do here is convey the techniques. You're absolutely correct. There are going to be some additional, the way you configure this from that perspective, right? And that's really where you're going to rely on your DBA. So your DBA is going to need to help you make sure you separate these out, and you want to make sure that when you're taking these snapshots, for consistency's sake, you want to make sure you do things like enable our VSS helper to make sure that we have a consistent, or we flush the log file and the cache on the database side. But certainly, there are a number of different considerations when you're setting this up. And if you'd like to chat about it one-on-one, not a problem. I'm certainly happy to help you. I've got some experience with databases, and certainly not meant to be, an all-encompassing thing. What I want to do is make sure you understand the concept, how we set this up, and how we go through setting up snapshot-enabled volumes with your particular database is going to be something that is done on a one-on-one basis, or you want to make sure you consult your database administrator for that. So with that said, guys, I'm going to go ahead and leave this open for a little while longer to allow you to go ahead and record any additional questions you might have. But we're going to wrap up the live portion of this. I did record this, so any of you that have arrived late or didn't get an opportunity to see the whole thing, you'll get an email with a link to the recording within the next 48 hours. You can also contact us directly if for some reason you don't get that email and you want to go ahead and see this live. You can certainly do that. So I appreciate everybody's time today, and really appreciate you coming out for the webinar. Look for us. We're going to be doing a series of these over the course of between now and the end of the year. You'll see a series from us, and we try and keep these as educational as possible. So hopefully you saw this as more than just a generic StarWind commercial. I appreciate everyone's time today, and look forward to hearing from you all real soon. Thank you.